Okay, Tele, I got an answer for you for the question you asked. So let's just go over that. So we have two charges. One is 3 microcoulombs, and the other is 2, or they're both negative microcoulombs, and they are separated by a distance of 1.2 meters. Correct? And we want to find out where the net electric force is 0. Well, if these were both the same charge, then the net electric force would be 0 right in the middle. But since this one is a little stronger, then the 0 is going to be moved from the middle. It's going to be somewhere here. Because if we're drawing field lines for this problem, field lines are going to go like this. Oops. And go into the negative, but this one over here is stronger. So these field lines are going to go in this way here. Okay? So we want to find out where it's 0, and what we're going to do is we can say that the net electric field equals the electric field caused by the -2 plus the electric field caused by the -3 microcoulombs. Oh, sorry, not micro, millicoulombs. And since this is 0 equals this, then we can just move one of these over to the other side. Now, first of all, remember that the electric field is going in opposite directions. Since they're both negative, the electric field for this one, for the 3, is going in this direction, and the electric field for the 2 is going in this direction. So one has to be positive and one has to be negative. So if I call this one negative, when I move it over to the other side, I simply get E of the -2 equals E of the -3. Okay, then we can plug in the formulas for those, which is KQ over R squared equals KQ over R squared. Okay, now here's where you have to outside the box a little bit. So let's go back to this diagram here. There's 1.2 meters between them. If I say that this distance from here to here is X, then this distance from here to here is going to be X. Oh, sorry, it's going to be 1.2 minus X. All right, so that makes sense. The distance between both of them is 1.2. If this distance to the 0, where 0 is X, then this must be 1.2 minus X. So now when I rewrite this statement over here, I'm just going to page, then it's going to turn out as follows. It's going to be 8.99 times 10 to the 9 times the charge of that one, which was 2 microcoulombs, so 2 to the -3, divided by the radius. And for that one, we said that the radius was X. Well, the distance is X. So it's X squared equals 8.99E9 times 10 to the 3E -3. And the distance here is right here, X, 1.2 minus X. 1.2 minus X all squared. Okay, and now it's simply a matter of solving for X, which is actually, it can be complicated because it's really a quadratic, but it actually gets simpler if you do it as follows. So multiply this out, multiply this out, and that's going to give you, that is going to give you 1,798,1,2,3,4 over X squared. And then multiply this out. That's going to give you 2,697,0,0,0 over, and we're just going to leave this. We're not going to multiply it out. Because if you multiply it out, then it gets very complicated. What we're going to do now is we are going to cross multiply. To solve for X, we're going to cross multiply. And when you cross multiply, you are going to get 1,789,0,0,0 times 1.2 minus x all squared equals 2697000 x squared. Okay, and once again, it still looks complicated at this point, but there's a little trick we can do here. We can just square root both sides. Square root. And the square root of this number is 4,240. And the square root of this value is simply 1.2 minus x. The square root of a square is just the number. The square root of this value turns out to be 5,193, and the square root of x squared is x. And now all of a sudden it's in a form that we can work with a little more ease. We can distribute here. Distribute, and that's going to give us 5,088 minus 4,240x equals 5,193x. Extend the page. Get this little guy over here by adding to both sides. So you're left with this equals 9,433x. And then you just do the division, and you end up, in this case, getting x equals 0.539, which, as you probably notice, is not the answer in the book, but that's the answer that we got for x. So this here is 0.539. Therefore, this distance here is 1.2 minus 0.539, which turns out to be 0.661, which is the answer in the book. So it's 0.661 meters to the left of the 3 millicoulomb charge, or you could say 0.539 to the right of the negative 2 millicoulomb charge. Okay, that's it. I hope that helps. It's a great problem. It is probably a standard of excellence question. So if you can do that one, then you're home free. Take care.